Well, good afternoon, everybody, and thanks to Catherine for making me look like a diva about my video. We do like to show that video from Autodesk because it does give everybody a view about the broadness of the technologies that we have and I guess the industries that we cover as well. So it's just a way of opening up the conversation, and also loud music after lunch always hopefully gets everybody in the mood. We are a software company, and one thing that's really important to us is, software can do a lot of things, okay, but it can't look you in the eye. Okay, it can't lend a sympathetic ear. It can't put its house on a mortgage because it has a really great environmental change idea. Okay, it can't make a promise, can't make a commitment. It can't take responsibility. People do that. So for us, our world at Autodesk is helping people imagine, design, and create a better world. So what does that mean? That's what we want to have happen by 2050. We want everybody to be living within the means of the planet. That's very, very important to us. And we have technologies that actually we think are going to be able to help that. But we also see, more importantly, the future as a design challenge. And we have to now start to recognise that some of the issues that we've created for ourselves can be solved by design. So now I'm going to talk a little bit about what we're seeing in product design and things that are changing, what's going on, and then how we hopefully can start to help everybody in this room work towards having a design-led revolution. So what's happening? One thing that we see all the time is product development changing. Okay, anybody that's been in the manufacturing industry for more than 3 years has seen some big changes. If you've been in it for 20 years, you've seen some massive changes. The way people collaborate, even the age of the people involved in design has changed radically over the last 10 years. The combination between small companies and large companies working together, technologies like Arduino and Raspberry have made a huge difference in the Internet of Things. Kickstarter programs, even our development ideology about how we make our CAD systems and simulation systems has changed by being more cloud-enabled, has been born in the cloud because people want a different experience for product development. Physical production's changing too. So again, anybody that's sort of read any newspaper or any magazine has understood about additive manufacturing, and then added on top of that, additive and subtractive manufacturing coming together. Machines that will be CNC, they'll build up products via laser sintering processes, and then you fine-tune them with CAM software. The material science that's coming out now to be able to enable different lightweighting, different textures, different abilities is just enormous. And I think the last one there, pop-up factories, is something, again, I've been in the manufacturing industry for a long time, although I look incredibly young. Okay, that was supposed to be funny. Right. One joke, I failed. But pop-up factories were not something that anybody could think about even 6 years ago. And now we're starting to see these factories being able to be put in a place where the production's needed rather than where it's more economically viable. Product intelligence. Now this is, again, we used to joke even 4 years ago, the only time that you don't need sort of integrated technology in a design process if you're making a skateboard or a rock. Well, guess what? Now people making skateboards, they want to know how fast they're going, how much it leans. They want to have some sort of GPS device, so a drone flying camera, GoPro, can follow them doing their fancy tricks. So you need to be able to have much more integrated technologies into what you're designing today and connecting it to the Internet of Things. And our expectations are changing. I mean, this is the lady there with the earphones is a company called Normal, and she just decided that her earphones kept falling out. So she now has a process where you can take a photo of your ear with a 25-cent piece, American 25-cent piece, to give it the size, and within 2 days you've got bespoke hearing earbuds for your ear. Again, not something we could think about, changing the way we view about mass producing something, and relatively inexpensive for what that process is. As I said, the materials are changing, the demands for people are changing, so everything about the manufacturing industry is just getting more and more exciting and more amazing. We're manufacturing buildings now. I mean, this is incredible to think about. In Australia alone, 87% of landfill comes from building waste, right? Can you imagine running a factory with 87% waste? It's just ridiculous. So now we're 3D printing houses on the brown one there. We're stacking houses. So again, the way that we think about how we construct things is blending into what we call the future of making things. And lastly, this is where I think the science has got really, really quite incredible. So for a long time, people used to say computer-aided design, but the reality was that you as the engineer would design the thing. The only thing the computer did was make it faster or easier for you. Now we can start giving constrained envelopes to the machine and say, right, I need it to fit, you know, in this particular manner with this particular joints, and it needs to hold this amount of weight and this amount of stress, and then the computer can start to generate that. You know, the Formula One teams are starting to experiment with that, and then they 3D print them in metal. So we're starting to see, again, a very different process for people designing and hopefully optimising for using less resources. So that's great. We have all of that going on in the manufacturing industry and in the industry in general. But we still have these issues. We still have massive urbanisation, desertification, we've got water problems, climate change. So we need to see an intersection of these technologies, you know, back towards the designers who are actually can make a big, big difference. So this is what we at Autodesk have the Cleantech Partner Program do, and what we're looking to do to help is what we're calling the design-led revolution. People with good ideas, social responsibility, hopefully investors with money coming together to give these new production methods, new ways of design, the opportunity to thrive and be successful. So let's look at a few examples of that. Here's some very European people on our program. I know there are speakers in the room who are on the program, but here's a few that we've called out. From Switzerland, our Agile Wind there for lightweight wind towers, Smart Hydro for doing power through hydro water in places like Brazil and where there's no off-grid power. Wello with the penguin, I'm not sure why it's called a penguin, but a very sophisticated way of wave energy motion, and one from London here, Vantage Power, who's going to cut a lot of the CO2 emissions from buses over the next couple of years. These are the sort of people that we invest in with our Cleantech Partner Program, which I'll talk about at the end, but I'll give you another example of a design process. This is a company called BioLite, and again, somebody that we helped as part of the Cleantech Partner Program. They saw a very big issue with, there's about 4 billion people who cook on open stoves in the house, and about 3 million related deaths from breathing in that black carbon. They said that's not really great, and usually these are in the poorest of places. So they developed the BioLite stove to overcome that. So basically what they decided to do was develop this particular stove that used you know, enormously less fuel, I think around about the 50% less fuel and 95% less emission. Okay, so it could start to really have a big impact on that process. They wanted to make sure that these stoves could get to, you know, the poorest of places. So they wanted to be able to design it in a way that was easy to manufacture and it was cheap enough to manufacture, but also had the right sort of intelligence in it that people, one, could use it, two, it added some extra benefits on top of the fact that it was helping reduce carbon, and three, that they could actually make some money on the other way. So here's a representation of it with a CFD process on it and thermal process. And what they found was they could actually use the process that they had for reducing the amount of fuel that they needed to burn. They could convert that into electricity, and they could then start to power either mobile phone chargers, or they could, you know, have lighting in rooms like this particular one, which again is something that is very difficult to come by if you're living in an off-grid environment in Africa. So that was all great, but they also needed to be able to fund the giving away or more or less subsidising of these units into Africa. So they were also then from that digital environment being able to create the camp stove here for the hobbyists. Now the great thing about this was that they started to produce well, they designed these camp stoves for people. They started to sell them, and they did that all off the digital process. So they started to sell their units before they actually made them, so that they were able to start funding through that process. Now, none of that is possible if you're designing with a pen and paper. None of that is possible if you're designing that with cheap software. None of that is possible without starting to get really sophisticated on the materials that you're using, understanding, what it is that, you might use a particular brand of plastic. How's it made? What's the CO2 output of that process? And you need sophisticated technologies to be able to do that. And we understand generally startup companies can't afford that. So back to these guys. All of these companies and some companies in the room have also benefited from the Cleantech Partner Program, which is our offer to any Cleantech startup. We give up to £100,000 worth of free software for the companies to use in their design process. That's it. We don't ask for anything in return. We occasionally put their picture on when I do some speaking events, or we use some more marketing stuff from them if they require. But basically what we want to do is give everybody who's part of that design-led revolution the opportunity to have the best possible impact in that process. So we're talking about, over the last 12 months, we've probably given in excess of £10 million worth of software away in Europe, and we want to continue to do that going forward. So really, that's all I wanted to say. I wanted to talk about the program and a few little changes. This is our handsome CEO who just thinks that the people that are involved in that climate change, and startups specifically, brave people, they should have the right sort of software to be able to do what they need to do. Thank you very much.